All right, welcome back to Database Development Design course. This is SQL Server. This is our SQL lesson for week 8, create tables and insert data. Okay, so this is, we're going to get into the idea of CRUD here. We've already done some of it, and it sounds funny, this is a real thing. So CRUD stands for create, read, update, delete. Create, that's today's lesson. We're going to build databases. Read, that's select statements. You've already done that. That's what we've been doing the entire time, mostly this class. Update, that'll be next week. And delete will be a part of today's lesson as well. Okay. Now, first of all, let me fix this. This code's a little off. So let me create table. It's the keyword. So this is the syntax to build a table in SQL Server. You'll say create table, give it a table name, and then you wrap it in parentheses. That as you don't need. That was for views. There was a little confusion there. So column one is data. Give column names. Give it data type. Column names. Give it data. It'll be easier once I show it to you. Once we actually build one. Here's some examples of some data types out there. The first one is nvarchar with an X. Nvarchar and varchar. You can also just do varchar, but varchar stands for variable character. It's like a string of some sort. So you put varchar of X. Let's say you had a varchar of 200. You can put up to 200 characters. It's variable. Versus char, when you put in two, it's looking for 2 characters. So char is not variable. I don't have it listed here, but varchar is. Nvarchar brings in characters outside of American ASCII. So if you're dealing with, European things like tildes or umlauts, or if you're dealing with Arabic lettering or Hebrew or Chinese or Japanese, anything like that, that's not part of the U.S. standard, then yeah, you probably want to bring in nvarchar. It does take up more space because it brings in that extra factor, but in most cases nowadays, that level of memory is not that much of a concern. If you're working on very specialized projects, yeah, but for most people, you can get away with this. Int is an integer. Decimal is float, so it's a number with something after the decimal point, which is an integer, has nothing after the decimal point. There are two numbers, and it's in the parentheses, x and y. The x is your precision. So the x is the size of your number. So if you put 10 as x, you can have 10 numbers. I'm going to write this down here. So let's say I picked for the decimal, I picked 10, 2. All right, so I could have 1, 2, 3, 4, 5, 6, 7, 8, 9. Or it could be this. It can be 10 numbers altogether, and you can have up to 2 numbers behind the decimal point. That's how you read that. Okay, sorry, go back here. This is wrong. It's not Boolean anymore. Now it's called bit. Change. So I fix that. Okay. Date. Set to U.S. settings. We use year, month, day. If obviously any other country, you do day, then month. Date time adds this, and you'll also sometimes you'll see that many seconds. So it's year, month, day, then hour, minute, second. And then we have something called an identity. Now this is not a data type so much as there's a auto feature. It's an auto incrementing number where the steps being x being the steps and y being, I say x being the starting number, y being the steps. So if you did 1, 1, it would be 1, 2, 3, 4. If you did 2, 2, it would be 2, 4, 6, 8. Okay. So main factor is it's auto incrementing, meaning it's really good, useful in a primary key because it won't reproduce itself. You won't get a duplicate key and it just automatically gives you numbers. All right. So let's build a table. This is an example of building a table with a primary key. So we can define the primary key by simply adding the word primary key after the column. So we sit there, we say create table. I just called this one stud info with parentheses. And I've got a stud ID. That's my student name, student ID. And it is integer. And it's a primary key. So as soon as you do this, I'll show you in a second here. It becomes a primary key. Then we have stud name, varchar 50, and varchar 50. That's you can put up to 255 is kind of the standard. You can go max, you can go farther, but and then you have birthday, which is a date. So let me go ahead and pop into my database real quick and show you this. So I'm going to pop over here. You change it so you can see what I'm looking at. All right, so check this out. So I'm going to say new query. We'll get there eventually. It's got to wake up. Then we're going to say use my database. We're going to say use DDD. That's mine. I created for this. And we'll just say create table. We'll just call this one student, just, as, and then I'll just say stud ID is an integer and it's a primary key. So I'm doing a little different than you see in the slide, just to show you a little different. And we'll have, actually, I'm not sure if do I have a table. Make sure I don't have a table called student in here already. Go over to my databases and say DDD tables. I do have a table called students. So let me go ahead and we'll just call this one students, just to make life easier. Or we can call it just student one. All right. So a primary key, and then I could have name, and I can make this an nvarchar. I'll put 255 if I want, and then I could have birth date, and I could have date for it. All right. So notice my name is blue because that's an actual keyword in SQL. But you can still use it as a column. SQL's a little more lenient on that. So let's go ahead and create this. Run these two together. Notice because my first line that I'm now in DDD, but I want to show you something here, okay? So let's go ahead, let's look at one of our other columns. So you see dog here, it just says order ID, all the, okay, notice I got ID, not null, whatever it is, all these things in here. All right, so what happens if I go ahead, now I got to refresh to find my ones I just put in there. And I go down, actually refresh the actual tables, sorry, refresh this system tables. And I look down at student one here. If you watch this now. See this? That is a primary. It says I got a key, and it even says primary key on there, right? And it gives it the not null. So it sets it up. You can't be null. You can't be a duplicate. All the constraints of being a primary key have now been applied to this. I just wanted to show you. You can see it right there in your database. Okay. So let's go back. So that's just building a basic table, and change over to this with a primary key. So we built a table, start info. All right. Now, if we wanted to do an identity, what we'll do is we'd create table stud info v1, and notice you still have to identify it. So this is still an integer. So I'd give it a data type first, then identity, then primary key. Identities don't have to be a primary key. What identity does is it auto increments. You don't have to worry about creating, and you'll see you can't tell it what it needs to be. Because it's auto incrementing, that's all it will do. It'll pick what it is. Okay. So this creates a table. Again, this is a primary key using an identity. And we'll see when we get to the lab, we'll play along with that some more. Okay. Alter table. So you can use alter table to change the table you built as it's already built. So this is fixing a table that's already been built. You want to alter. So we could alter the table stud info. We could add a new column called GPA decimals to, and this creates a column called GPA. And notice I don't have to use the word column. So just by adding, it knows that I'm going to do it. So I can do the same thing again, or I can alter a command, use alter existing columns as well. So I can say stud info alter command. And now I've changed GPA to an nvarchar 3. Okay. So go ahead in here and I can show you again. We could go to here and I could just say alter table student one. And I could say add GPA, and I'll just call it varchar 3, So if I go there and do this, now if I go back to my student here on the right and I refresh, you can't see it because it's, I hit the properties. I hit properties by accident. 1 second, let me refresh again. So refresh. Now when I open my columns back up, I now have a column called GPA and it's a varchar 3. So that's altering the table and you can get in there. Let's go ahead to the next one and we will look at inserting data. So good, database isn't much good if you don't need data to insert in there. So here's an example. We're inserting command into the data tables below. So you'd run insert into stud info values, and we'll see this in the lab. We pretty much almost follow this exactly in the lab. I'm not going to go too much into SQL Server here. You'll notice there I've got so the commands are insert into, name of the table, then I have values. Okay, values tells me I'm putting data in, and I have these tuples, these sets of values separated by a comma inside parentheses, and the parentheses and notice each tuple is separated by a comma too. But see, I've got 1, 2, 3, 4 to match the 4 data columns we have now. If you remember now, we had 3. We had ID, name, and birthday. Then we added GPA. Okay. So now we go up to here, and this is ID, name, birthday, GPA. If you have all the columns you want to fill, you're good to go. You can do this. If not, if you only want to add data to certain columns, you can add the column names to the insert commands. Now I have insert into stud info, and I have the column name, stud ID, student name, GPA. I don't have birthday. I don't have a birthday for this person. I don't have Scooby-Doo's birthday. I don't know his birthday. So now notice, but we line up. So now the first is his ID, the second is his name, and the last is his GPA. Don't have his birthday, he's got pretty good grades. So that's another thing you can look at based on the fact that, if you don't have values for every column, you could have also skipped that and just put a null in there for the GP for this birthday. Another option you could have gone with. All right. So when we have an auto incrementing column, however, though, you want to make sure you do not provide a value. I'm going to show you this in the lab. I'll do it. I'll give it a value, and it's going to fail. So notice here, I've got my student info V, which only has, when we made this one, this table only has 3 columns, ID, name, and birthday. We never gave this one GPA. So I only need to provide the name and birthday, which is all I've got here, student name and birthday. If I try to provide a value for the student ID, it will fail. You notice here it's going to give me an auto increment of 1 and 2 here. I'll show you in the lab. You can see how it works. Okay. Now, foreign keys. You can make a foreign key as you make the table. I'm just going to put this as advice for when you first start trying this. Maybe, build your tables first, then add the foreign keys. So here's an example here. We got this stud info table, and I want to create a foreign key called another table called grades that will have a student ID that will be the foreign key related to the stud info v1 table. Okay. So this will be my foreign key connected to this table. So again, you can do this all in one step, but I'm showing you 2 steps because I think sometimes it's easier. Build all your tables first with your primary keys, and then we'll come back and we add the foreign keys. Now you have to make sure that the key with the primary key is the first one built. So this, if you don't have this table built first, you cannot create a foreign key. Okay, so build the tables, and then we come back here and we say alter the table grades. So this is the table that has the foreign key. This is our foreign key right here. So we're altering this table, alter table grades, add foreign key is our keyword, and then in parentheses, we have the name of our foreign key, which is our student ID here. Again, this column is in this table. It's not here because this table has a stud ID. Then we say references stud ID v1. So it references this table, and it references stud ID. So what we're saying is alter this table, make this column a foreign key, and say that it references this table, this column. Okay. Read that over as many times as you want. You can look at other ways to add it. I'm just going to recommend this is how you do it, especially at this level when you're first still getting used to this whole thing. Okay. So real quick now, let's go into some different ways we can get rid of. Okay. So now we've built our tables. I'll quickly go into getting rid of tables. Now we're going to drop a table. So dropping a table deletes everything. So you'll notice here I've got this table called stud info. I drop table stud info afterwards. There is no more table there. Not only is the data gone, the object is gone. So whether it's a stored procedure, a view, a table, a user-defined function, drop just deletes the entire object. Okay, not just the data, but the object. Then we have 2 other options where we have truncate. Truncate deletes all the records from the table. So truncate table stud info 1 will delete every record from the table, but keep the table. Delete will delete all the records from the table too, but with delete, you can add a where clause limiting the records to delete. So in this case, I can say delete from stud info v1 where the name is Scooby. This will only delete the record with Scooby in it. This is going to delete all records. The table will still be there, but so notice this one says truncate table. This one says drop table. This one says drop from. So delete from. So this is different. So delete is the only one with a, and that's a mistake. You got to get rid of that. Delete's the only one with a where clause. Okay, so the other two. All right, so let's go ahead. I will see you next in the actual lab walkthrough, and we'll kind of explain a lot of this.